In this video, I will be going over an introduction to a function called a logarithm. So first, I'm going to start by reviewing the exponential function. Which looks like y equals b to the x, where b is positive, or in other words, greater than 0, and b does not equal 1. So b here can be any number that's greater than 0 and not 1. So on the graph, we're going to have the point 0, 1, because when we plug in x equals 0, our y will always be 1, no matter what our b value is. And this function is 1-to-1 because it passes the vertical line test, which means that when you look vertically at the function, only one point is there. And since it's 1-to-1, this function has an inverse. So when you're solving for the inverse, you're going to change the x and y values. So I have x equals b to the y, and we would want to solve for y. And that new y you get would be your inverse function. So here the inverse will be y equals log base b of x. So our b is considered our base. And this log function is going to reflect over the line y equals x. And here for our log function, we have the point 1, 0. So for these functions, we're just going to be rearranging where the b is based on whether it's a logarithm function or an exponential. So the first question asks to write in log form when we start off with exponential form. So I have 3 to the 4th equals 81. My 3 is going to be my b value. So I'm going to take log of 3, log base 3 of 81, and set it equal to 4. So you kind of go in a counterclockwise direction starting from the base. My next example, I have 1/2 to the negative 3 equals 8. Once again, my b value is going to be my 1/2. So I have log base 1/2 of 8 equals negative 3. So I went in that counterclockwise direction again, starting from my b. Now in these next two problems, I'm going to do the opposite. I'm going to start from logarithm form and convert it to exponential form. So my first example is log base 6 of 36 equals 2. So here my base is 6. And going in that counterclockwise direction, I'm going to do b to the 2. So in other words, 6 to the 2, and set it equal to 36. My next example is log base 1/2 of 16 equals -4. My base is 1/2. And I'm going to take that to the -4 power and set it equal to 16. Now this example is asking you to solve for b, so we have log base b of 81 equals 2. So we're going to take b to the second power and set it equal to 81. So b squared equals 81. Now we're going to take the square root of 81 and we get plus or minus 9. But b is going to equal 9 because b is greater than 0, so it can't be negative. Now we have log of 36 of 6 to the 1/4 equals y. So we take 36 to the y and set it equal to 6 to the 1/4. 36 is the same as 6 squared. To the y, we set that equal to 6 to the 1/4. And now using exponent laws, if you have a power raised to a power, you multiply those two. So we get 6 to the 2 times y equals 6 to the 1/4. That means 2y equals 1/4 because we can ignore the base as long as they're equal. Then after dividing 2 to each side, we get y equals 1/8. Now the next problem asks, we have log base 2 of x plus 4 equals 8, and we want to solve for x. So here first we can subtract 4 from each side, and we get log base 2 of x equals 4. And now rearranging this into exponent form, we get 2 to the 4 equals x. And 2 to the 4 is 16, so x equals 16. For the next example, we have 3 log base t of 9 plus 6 equals 12. So first we can subtract 6 from each side. And now we can divide 3 from each side. So we get log base t of 9 equals 2. Now converting this to exponent form, we get t squared equals 9. And so t equals plus or minus 3. But since our base number has to be greater than 0, we'll get t equals 3.